So trusses, this is the one we're going to do. All right, do you have your little half sheet with the notes on it? Find a little half sheet somewhere that you can at least see. All right, what is the first step? You do have to answer.
Replace the pin and roller joints with reaction force.
All right, so we have to replace the joints with the pins and roller joints, so these, with reaction forces. All right, let's label this A, B, and C. So we have just points to go by. All right, this is a roller joint. How many forces does it get?
2.
One, because it can only stop movement in one direction. And it's in the Y direction, so I call it reaction force at joint A in the Y direction. So I call it RAY. All right, the pin joint can stop motion in two directions, the X and the Y. So I need one going up, and I'm going to call it RCY. And then I'm going to do one in the X direction and call that RCX. Okay, that was step one. What's step two?
Find the external forces.
All right, find all the external forces. What are the external forces?
120 and 40.
Okay, 120 and 40 are, but what are the ones you don't know?
We don't know the RAY, RCY.
Yeah, all the ones we just wrote in, right? All right, so to find the external forces, we only have 3 equations, and I'm telling you to start with the sum of the moments equals 0. Okay, remind me what the formula was for moment.
It is.
Some of the X's and some of the Y's.
Nah, that's the sum of it adding up to 0. Moment is force times distance,
Okay.
but what type of distance? Parallel or perpendicular?
Parallel.
Nope, perpendicular. So it's the perpendicular distance. All right, because moments are what causes rotation, right? So it's going to be the distance perpendicular to the force. All right, so we are always going to pick the pinned joint to be the point of rotation, or to kind of be your fulcrum. To be point of rotation. Okay, so that's C for us, right? So I'll put a green dot. That's our point of rotation. What forces that are external forces are going to cause this thing to rotate if I pin this down and don't let the joint C move? What forces are going to cause it to rotate? RAY and these two. Okay, so the sum of the moments equals 0. Okay, RAY. If I push up on RAY, is it going to cause this thing to rotate clockwise or counterclockwise?
Clockwise.
Clockwise, so it's negative. So negative RAY, and it has to be times the distance to the pin, or to your rotation point, perpendicular to the force. So it's this distance here, and we're just going to count blocks because I didn't write numbers on here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this length is 8.
1, 2, 3, 8.
Okay, so that's going to be clockwise. That's why it's negative. All right, now the 120. If I push on it here, is it going to make it rotate clockwise or counterclockwise? Counterclockwise. So that one's going to be positive. Because think about if I put my finger on the green dot and then I pushed my card down. Which way is my card going to rotate?
I got it.
All right, so 120, what's the perpendicular distance?
You gotta do some math.
No, you're counting blocks.
1, 2, 3, 4, 5, 6. 6.
1, 2, 3, 4, 5, 6. Yes. Okay, then 40, if I push that way, is it going to go clockwise or counterclockwise? Clockwise, so it's going to be negative 40 times what's its perpendicular distance?
4.
1, 2, 3, 4. All right, so y'all are going to have to do the math because I don't have a calculator and I don't know.
8 plus 1.
So RAY is going to equal
Hold up.
Plus negative 40
That's negative 160.
I got 558.
You got 558?
Yeah,
Oh.
568. Sorry.
568?
I have math. I don't know if I put it in correctly. Andrew, check.
Yeah, check her math.
That looks about.
No, I don't think it is. That's what I'm saying. Check her math.
720 minus 160 is not 560. So it's do 720 minus 160.
Here, grab another calculator. Oh, that one doesn't have batteries.
Oh, that helps all.
Yeah, get
We
your
need
phone.
Aiden. Or some.
I know, we need Aiden.
Smart
How do
person.
they just do it in their head?
I can't.
I can't.
I have to write it down.
I got 888.
I got 568 again.
I got 560.
Okay, y'all are crazy.
It's 560.
Is this the messed up calculator though?
Hold up, there's an 8.
Yeah, but you're not doing it.
560 divided by 8.
Oh wait, minus
70.
That's what it's supposed to be.
Yeah.
What?
70.
That's what it's
How
supposed
did
to
you
be.
get that?
You got 560 on the top, but did you divide by the 8?
No.
No, well, that's why.
Crazy.
I got 1/2. Wait, no.
No.
Wrong number.
Wait, but is it negative 70? Yeah, good negative.
No, because RAY is going to move to
71.
the other side, so it's now
I got
positive.
71.
Oh, right.
Okay.
So I got the right number. I just didn't complete the problem.
Okay,
Wait,
so
so where'd you get the 8? Where?
right here.
That's the number of blocks.
Yeah, but that's not.
So if you do algebra and you move the negative RAY to the other side of the equation, and then you have your 120 times 6 plus your negative 40 times 4, this was where you got 560, and you still have 8 times RAY. So RAY is, yeah, you got to divide by the 8. Okay, so that's 70. Now, how are we going to find RCX and RCY?
We're going to.
Put the fulcrum over there.
No, we're not going to use moments anymore. Now we have to remember there are 3 variables. We need 3 equations. So that was one equation that we used. Now we're going to use the sum of the forces in the x direction equals 0. And then the sum of the forces in the y direction equals 0. All right, what's pointing in the x direction?
Where are you running?
Rex.
Oh, right here.
RCX.
Would it be easier if I erased and redid it?
No, you're
So,
good. I just.
RCX equals 40.
Okay, RCX is in the x direction and 40 is in the x direction. You're right, it does equal 40, but I'm going to go ahead and write it out.
Okay.
So RCX is going to be negative because it's pointing left, right? Because now we're not doing moments, so we don't care about clockwise and counterclockwise. Now we need left and right. So left is negative, and then 40 is pointing right, so it's positive. And then if you solve that for RCX, then RCX equals 40.
Yes.
All right, then I'm going to go right under it and do the forces in the y direction have to equal 0. Well, which ones are in the y direction? 120. Is that going to be positive or negative?
Negative.
Negative because it's pointing down. And then RAY, which we already know is 70, and it's pointing up, so that's positive 70. And then RCY, we have it pointing up, so we're going to leave it positive. Now we're going to solve for RCY. It's going to equal
12 minus 5.
50.
Negative 50.
It's going to be positive, though,
Because it is.
because one has to, because you got to move one to the other side of the equals.
Oh, so it just is by default positive.
Yeah, it's positive, right? Because if this is negative 50 and you moved it to the other side of the equals, it's positive 50.
Okay, that's pretty good.
So this is 50.
RAY. 70. Did we get that already?
Yeah, RAY was 70.
Oh,
We did that from the sum of the moments. RCX was 40. So really, here's an answer, here's an answer, and here's an answer.
Again, I
Now we
understand
have to
the
do the thing
concept,
with the
but
Yeah, that's kind of the easy part, right? That's all the external forces. Now we need to find all the internal forces. So now we need to draw free body diagrams for each joint.
Not we.
Yeah, All right, I'm gonna draw them different. Last time I drew them all in a line. This time let's draw them like they are on the truss, and you can see which way you like it better, so you can do it. All right, I may have to flip back and forth to draw, but you can see it. Okay, so we're gonna do joint A down here. So joint A has a member going that way and one going that way, and it had RAY, which we knew was 70. This one we were going to call AB because it's going to joint B. This one we're going to call AC because it's going to joint C. Then up here's B, and B is going that way, and it had one going that way, and it had one going that way that was 120. And it had one going straight that way that was 40. I obviously did not draw them to scale. Yeah, this one is still AB. This one is BC. Okay, and then let's do joint C over here. So C had one going this way, which was BC. And it had one going this way, which was AC. And it had one going up, which was 50.
Possibly.
Was it?
Yes, it's 50.
It was 50. And then, sorry, I had to flip to C. And then it had one going this way that was 40. Now my arrow runs into my C, sorry. Okay. So now the only two equations we can use are the sum of the forces in the x direction equals 0 and the sum of the forces in the y direction equals 0. So we only have two equations, so we have to start with a joint that only has two unknowns. Which one would you like to start with?
Any of them.
So do some of these repeat?
C.
Yeah, they repeat. Yeah, because
A,
whatever...
A, C, A, B.
Right. Can you see how the truss looks like it's together right here?
Yeah.
So whatever we calculate AB to be, that's the same number that's going to end up over here.
Let's
Yeah.
do joint C.
So this is not.
You want to start with joint
You
C?
left it off seeming way more complicated than.
Okay, well that's why I drew it this way. I thought maybe that'll help you see it
That
better.
helps me. It's like
Would
C.
AC be 40? Right off the bat. Would it?
No.
No?
No, because this one, any of them that are slopey, right? If you have slopey lines, they have an X component and a Y component, remember? So any of the slopey ones we're going to have to resolve into X's
How
and
do you do
Y's.
slope again?
We'll do it because we'll have to do it with that one. All right, so let's do
It's 33 point.
the sum of the forces in the Y direction for this one.
Okay.
What's going in the Y direction on joint C?
50.
50. Is it pointing up or down?
Up.
So it gets a positive. So it's positive 50 plus, what else?
The Y, BC, Y.
Yeah, the part of BC that's in the Y direction. So this BCY part right here, right? Okay, how do we know this angle.
Yes.
What was that angle?
33.69.
Yeah, okay, I can't write all that in there. Okay, so if that's the angle, how can I find BCY?
Sine.
Sine. So the sine of 33.69 is going to equal the opposite, which is BCY over BC. But I need just the BCY part. So if I resolve that, right, it's BC times the sine. Can I just round that to 34 just for sake of writing?
Sure.
Okay.
Don't make me know.
So that is what I'm going to plug into my equation. Okay, so we're going to plug in, and is it pointing up or down?
Yeah, upward.
Upwards. So it's BC sine of 34. So now can we solve for BC? Yes, because all of this has to equal 0.
Oh.
So BC is going to equal negative 50 divided by the sine of 34. Make sure you're in degrees, by the way. And that yellow calculator does not like degrees. What are you talking about?
The correct answer.
Wait, why is 50 negative?
0, 0,
Yeah,
0,
89.4.
Wait, why is 50 negative?
5.
What?
It's
Oh, because when you move it to the other side where the 0 is, it becomes negative. So this comes out to be negative 89-ish.
So this one does not like.
And because I rounded to 34, like my answer sheet actually says 90, but because I rounded that to 34, so it's fine. I'm going to see your math, because if I don't see your math, I can't carry your error through. And if you make a mistake at the beginning, I got to be able to see your math all the way down so I can still give you credit, right? Just because you got one part wrong, you need to be able to get the rest of it right. All right, so that's negative 89. So that's BC. What that negative tells you is that that arrow is really drawn incorrectly. So we either have to flip the arrow and change that to a positive number, or we leave it alone and we keep the negative. But whatever we do here at BC, we have to do here at this joint. I tend to leave the negative and not bother with the arrows. Okay, well then let's just do it my way, and then if you want to see it the other way, or if you watch somebody else's video, or even the Project Lead the Way PowerPoint, they flip arrows. But to me, you forget to flip the other one and then you mess up. So I would rather leave the negative. Okay, so now we know BC is negative 89. I'm also going to go ahead and put it up here. Okay, now we can find AC. So what equation are we going to have to use now?
X.
Yeah, the sum of the forces in the x direction equals 0. All right, I'm probably going to have to run out of room. I'm going to do it up here. The sum of the forces in the x direction. Okay, what's acting in the x direction? 40 to the left, so it's negative. Perfect. What else?
AC, or
Yeah, AC,
AC,
which is pointing.
that way.
So
left.
it's negative AC. And I don't have to do sine or cosine or anything because it's flat on the axis, right?
Yeah.
All right, and then what about BC?
Don't worry about it.
I have to worry about it.
BCY?
Well, now we need BC X because we need that part. So this is going to be, and it's pointing left, right? That arrow is pointing in the left direction.
Yes.
So this one's going to be BC sine of 34. Well, what do we already know?
DC.
We already know BC, so let's rewrite it. Oh, and all this has
It
to
would
equal
be
0.
Sine.
Oh, no, it wouldn't be sine. You're correct. What would it be?
Cosine.
It would be cosine. Whoop. Like erased it and rewrote it. It would be cosine of 34. All right, good catch. Why, and we know this number, why is it cosine and not sine?
Because it's adjacent.
Yeah, it's adjacent. See it? It's adjacent to that angle. So yes, it is cosine. Okay, so, but we know BC. So we're going to say 0 equals negative 40 minus AC minus a minus 89 times the cosine of 34. Why do I have two minuses?
Because you
Because
have
it's-
to,
you do.
because that's a negative.
Yeah, this says it's pointing left, and this is because we left the negative on our answer, right? So that's why they're there. Okay, solve for AC.
Yes, ma'am. I got that.
You should get,
33.
yeah, because the answer on here is 35, so 33, 34 or something.
34.
We got 34?
We sure did.
Okay.
Didn't we?
I don't know.
Yes,
how y'all did
Yeah.
yes,
that,
we
but
got 30.
Do I need to write the math out?
I wrote the math
Ian heard.
out. I just didn't put it in the calculator.
What did he do?
It's gonna, okay,
I think
you can see if you get 34. It should be around 34. All right, so that gets you BC and AC.
I'll take it.
So I can go over here and put AC over here now that I know it. What do I have left to find?
AB.
AB. Which one would you like to do? Joint A or joint B?
Joint A.
Joint A, because it looks a lot simpler than joint B, right?
Yes.
Yeah, pick joint A. Same thing. You're going to have to do the sum of the forces in the X and sum of the forces in the Y. It does not matter which one we start with. Which one would you like to start with?
Let's start with force
Y?
Y.
Connect these together.
All right, so what's in the Y direction around joint A?
70.
70. Is it positive or negative?
It's positive.
It's positive because it's pointing up. What else is in the Y direction?
120? 50. What?
No, it's this A,
Oh.
B, Y part, right?
Yes.
So that, how am I going to write that in the equation?
Abby.
It's going to be AB times the sine or cosine of this angle. Sine, and what's that angle?
It is 63.435.
63 point what?
435.
Oh, we're just going to call it 0.4. That's good enough.
All right.
Anything else in the Y direction?
I don't want to say anything.
You're right, there's not. So now solve for AB. So AB is going to be negative 70 over the sine of 63.4.
I still don't get why you changed 72.
Which makes it
Because I'm moving it to the, this whole thing's equal to 0, so I'm moving it to the other side.
78.
No, but it's like.
Like, I'm doing like minus 70, minus 70.
78.3.
What do you get?
78.3.
Give me a second. I'll double check.
Positive or negative?
Positive.
I don't think so. Negative.
I agree.
Why
Thank
is
you.
it negative?
Because we had a negative 70.
That's true.
Oh, we did? I thought it was going up.
But when I move it to the other side of the equation, it becomes negative.
So are we done?
Yeah, you're, well, almost done.
Is that
I
it?
meant like for
Yeah, you're done finding numbers.
external.
Oh,
No, these are internal.
I mean,
hold up.
These are internal.
We already did these.
Question mark.
Uh-huh.
So,
See?
what if we find ADX? The X component.
Well, we can.
Would it be the same?
Yes. So let's check ourselves. In fact, I would do that to check yourself.
Okay.
Let's do the sum of the forces in the X direction. We're going to do the other one to make sure, because we should get the same number. So you need to check yourself anyway. All right, so the sum of the forces in the X direction equals 0. What's acting in the X direction? AC, positive or negative?
Positive.
Positive. Plus, what else is in the X direction?
Cosine AB.
Yeah, AB cosine of 63.4. And we already know AC from the other problem. So it's going to be 0 equals 34 plus AB cosine 63.4. So move your 34 over
75.
and divide by cosine of 63, and that will equal AB.
What was that?
So tell us what we get.
Oh my god.
Get it. It just
70,
clicked.
76?
Good. What? Should be the same number.
Should be.
Well, maybe our 34 is rounded a little bit because we used that other angle over here.
It might.
It might be off a little bit. What did it come out?
75.9.
Oh, that came out a lot, but okay. It's because we rounded this, it's because I rounded that angle and I didn't round that angle. That's why they're off a little bit. Okay, but you should theoretically get the same thing because you're solving for the same thing. All right, the last thing you have to do is redraw the truss and understand what the negatives now mean.
I got this.
Okay, all right, so redraw your truss, and this time we're going to put everything in. All right, I'm not drawing anything to scale, or straight for that matter.
It's okay.
Nothing in the world is free.
You just call Miss Mayfield.
It's okay, Miss Rose.
Okay.
You call her Miss Mayfield?
Which way was our 40 going? Which way was our, I got to go look at our picture. This way.
I knew. I knew that.
No, I wasn't listening. All right, this was 70, and this was 50 and this was 40. All right, now, how do we put these member forces in? When they are negative numbers, you are now going to write, what did we get, 78?
Hold on.
And then we're going to put a C in parentheses. Because our 78 came out negative, that tells us that that beam is in compression. So you're putting a C for compression. And then over here, didn't we get 89 negative? So now we're going to write 89 in compression. And then down here, we got a positive 34, 35.
Positive 34.
All right, then that one's in tension because it was positive. This is the answer to the problem.
Whoa.
So that's what you have to redraw.
I don't.
So negative.
like
It's not hard, it's just very
Okay,
tedious.
so negative compression,
You and me are
positive
both.
tension.
Correct. Negative for a member equals compression,
What are you, stupid?
and positive equals tension.
You're not stupid.
All right, let me stop the